Alrighty, welcome. So today we're going to be looking at completing the square. Now, before we looked at factorizing, in order to turn this shape of the quadratic into a slightly easier one, which is the factorized form or the root form of the equation. Well, completing the square doesn't do that. Completing the square converts it from this form into this form, which you may remember is the turning point form. So the goal of today is to turn quadratics that do not look like quadratics that don't look like turning point to look like turning point. So essentially the goal of today is to go from the general point to the turning point. I'm going to do that by completing the square. Now, let's talk about this term right here, which is a perfect square, meaning it is two things squared. Let's have a think about that shape in general. So if I have something like p plus q squared, what's that equal to? Well, p plus q squared is p plus q, p plus q, p times p squared, p times q, pq, q times p, and q times q. Collect those middle like terms, because these are both pq, pq. We get 2pq. So essentially we've got a squared thing at the start, a squared thing at the end, and 2 times the not squared of each of them, so p times q. So let's have a look at a quadratic and see if we can use this to actually work backwards. Alrighty, so let's look at this one. We've got y is equal to x squared plus 6x plus 5. Okay, this is going to be the strange step, and this is the step that most people get confused by, so watch really carefully. I'm going to take this middle term and divide it by, and I'm going to take the constant from it, so I'm just going to look at the 6. What I'm going to do with that 6 is I'm going to divide it by 2, and I'm going to square that. And I'm going to add that and then subtract that. This is going to look like the strangest step of the whole thing. X squared plus 6x plus 5. And what am I going to have? I'm going to get plus 6 on 2 squared minus 6 on 2 squared. Notice I haven't changed it because all I've done is added something and subtracted something, but because I've added and subtracted it, no foul play. Okay, now let's have a look. What have I got? I've got x squared plus 6x plus, well, 6 over 2 is 9, 6 over 2 is 3, 3 squared is 9, minus 9 plus 5. So hopefully you can agree I haven't actually added anything, because when I add 9 and you subtract 9, well, you haven't added anything. But look at these 3 terms now. They actually fit this pattern, which means that we can go straight from this pattern back to the top, like when we're doing difference of perfect squares. Now, just to clarify that really quickly, we've got a squared term, we've got a squared term, and in the middle, we have got 2 times p times q. 2 times x, this would be 2x, times 3, which was the 6 on 2 that we got from before, is 6x. So all of the terms actually match up, which means we can immediately turn this triple into, well, x plus 3 squared. Okay? Right, we can keep writing this as 3 squared if people would prefer, just to see that it really is that pattern. So we can factorize it straight to that. That's what this rule up the top says, is that if you expand it, you get that, therefore you can factorize it back there. But I'm left with this minus 9 plus 5, so that's minus 4 on the end. And there we go. Now, obviously we like this because it tells us the turning point really quickly. Like we can see quickly that the turning point is equal to -3, -4. That's the turning point of this particular quadratic. That's nice. There's nothing wrong with that, but there's another reason we might want to have this information. And the other reason we don't mind this format is that it's actually a lot easier to find the X-Intercept. So X-Intercept is when y equals 0, 0 is equal to x plus plus 3 squared minus 4. Add 4 to both sides. 4 is equal to x plus 3 squared. Take the square root of both sides. Okay, it's an even root, so it's plus or minus. So it's plus or minus the square root of 4, which is 2. X plus 3, subtract 3 from both sides, and we get plus or minus 2 minus 3 is equal to x. So we've got two solutions. x1 is equal to 2 minus 3, or negative 1. That's when we take the positive, and when we take the negative, we get x2 is equal to minus 2 minus 3, which is minus 5. All right, I'm going to do one. I'm going to have it go through another one. Alrighty, so let's have a look at another one. Oh, actually, no, I'm going to change this one just slightly. Alrighty, so let's look at this one instead. Slightly different. It's going to make our lives a little bit more difficult. So let's remember that first step. Remember, in the back of our head, we know that x plus b squared is equal to a squared plus 2ab plus b squared. It's the same rule I wrote up before. In this case, though, it's probably going to be a minus, which the only thing it changes is that middle term. Okay, so these are the two rules we need to know. You can expand both those for yourselves if you want to double check, but it's the same thing that we did before, and if you do it, you'll find that it does indeed work. So let's go through and see if we can complete the square here. So take the middle term, negative 5, divide it by 2, square it. So y is equal to x squared minus 5x. And we're going to add and subtract this. Add negative 5 on 2 squared. Subtract negative 5 on 2 squared plus 7. Now in this case, it's going to look a little bit ugly, but it is going to work. We're going to have x squared minus 5x plus really 5 on 2. The negative doesn't really matter, but let's keep it in there. Minus, and then we could just start simplifying everything else. But these three terms, in fact, fit this rule, which means we can factorize. X minus 5 on 2 squared. Minus, and then this is where we're just going to keep all of this other stuff on the end, so this would be minus 2.5 squared plus 7. Minus 2.5 squared is 6.25 plus 7. And y is equal to x minus 5 on 2, or x minus 2.5 squared minus, in this case, oh sorry, plus 0.75. Therefore, the turning point is just 0.75. Alrighty, so this does look a lot worse, and we're going to have to look at one more scary version of this before we move on. Sorry, that's not the turning point. The turning point would be 2.5, 0.75, using turning point rule. But once again, we could look at the roots, but we'll look at that in a moment. We're going to look at one more version, and then we're going to take find the roots of that one. Alrighty, so we've got one more to look at, and that's going to be the non-monarch. Now this is quite a challenging one, so it will take a lot of practice to be able to do these really effectively, but we're going to have a go at trying to do it ourselves. Step 1, the rule we've learnt has got to be about things that look like a plus b squared, meaning we can't have this coefficient out the front. So we need to get rid of it. Now we're not allowed to just get rid of things we don't like. We have to divide them out. So I'm going to factorize it out. So take the 3 out the front. I'm left with x squared plus 5 on 3x. And then the minus 3, which is just a tag along, is going to hang out alongside. Now I'm going to do that rule, that divide by 2 square it. So take the term here, 5 on 3, divide it by 2, which is 5 on 6, squared. And I'm going to add that and subtract that. Where am I going to put it? I'm going to put it inside the brackets. Alrighty. So it's getting pretty messy, but now since I've set it up correctly, this whole thing is going to be my perfect square. So I can, it's a positive perfect square because it's got the plus here. I can take it out and it's going to look like x plus 5 on 6 squared. That's what that whole chunk becomes. And we're left with minus 5 on 6 squared on the end. Ooh, I forgot the minus 3 on this line, and the minus 3 is still coming along the journey. Now this part's finished. The problem is I've got 2 sets of brackets and I only need 1. So I'm going to, I've actually got 3 sets of brackets, but let's worry about this one a little bit later. So the first thing I'm going to do is I'm going to expand these brackets. So it's 3 times that, 3 times that. And then 3 times 5 on 6 squared minus 3. Now this left bit is all done. That's ready to go. We're all happy with that section. This is now the mess that we've got to clean up. So the first thing we're going to do is get rid of this a little bit, make it a little bit cleaner. So y is equal to 3x plus 5 on 6 squared minus, and then we've got this. So 5 on 6 squared is 5 squared on 6 squared, which is 25 on 36, times 3. 25 times 3 is 125. However, oh sorry, 75. But 75 and 36 both have a common factor of 3. So I can divide top and bottom by 3. So I'm left with 25 on the top, 12 on the bottom. No more common factors between top and bottom, minus 3. But I want to combine these 2 terms, which means I need to write both of them in twelfths. So the 3 is going to become 36 twelfths times top and bottom by 12. And minus 25 minus 36 is minus 51 twelfths. Oh, sorry, minus 61 twelfths. And that is our final answer, meaning our turning point in this case is negative 5 on 6, negative 61 on 12. And you could go through and try to solve the root of this one, but it's pretty tough. Alrighty, I'll see you on the next one. Goodbye.